Warm welcome to all students. This subject is electrical traction and control, and the topic which we will discuss today is specific energy output and consumption of chapter number 2, mechanics of train movement. Objectives covered will be energy output from driving axles, the specific energy output, specific energy consumption derivation, and factors affecting it. Energy output from driving axles. Now, before concluding this, we must know what is the power output from the driving axles. Now, power is rate of doing work. That means tractive effort into distance upon time. એટલે કે tractive effort into speed. So, the energy output, assuming it as a trapezoidal speed time curve, તો total energy run માટે required છે, that will be acceleration વખતે લાગતી energy plus free run વખતે લાગતી energy. We can further elaborate it as average power during acceleration into period plus average power during free run into period of free run. So the final equation which we will get will be E will be equal to half FTVM divided by 3600 into T1 by 3600 plus FT dash VM divided by 3600 into T2 by 3600 kilowatt hour. Here Ft is the tractive effort during acceleration period, while F dash T is the tractive effort during free running period. So this is how the energy is calculated. Now talking about specific energy output. Specific energy, it is the energy output of driving wheel and it is expressed in watt hour or per turn kilometer of that particular train. It can also be found by first converting energy output into watt hour and then dividing it by the mass. So train in turn and route distance in kilometer. So finally the specific energy output which we will get will be WH per turn kilometer. This is how it has been expressed in units. We will first have to calculate the total energy output on driving axle, after that divided by the train mass in turns and then route length in kilometer. તો સ્પેસિફિક એનર્જી આઉટપુટ આપણને આ રીતે મળશે. આમાં ગ્રેડિયન્ટ G હશે, થ્રુઆઉટ ધ રન હશે અને પાવર વિલ રિમેઇન ઓન અપ ટુ ધ એન્ડ ઓફ ફ્રી રન ઇન કેસ ઓફ ટ્રેપેઝોડિયલ કર્વ. નાઉ એક્સેલરેશન પીરિયડ હશે ત્યાં સુધી in case of quadrilateral curve. So output on driving axles is used for three purposes. First one is for accelerating the train, second one is for overcoming the gradient, and third one is for overcoming the train resistance. As you can see in this graph, on x-axis we have time which is in second, and on y-axis we have speed which is in kilometer. So firstly, the energy required for train acceleration. The final equation which we will get for energy required during acceleration will be 0.01072 multiplied by Vm square divided by D multiplied by We divided by W. If you remember the equation of tractive effort which was been required during acceleration, એટલે કે force required during acceleration, એના પરથી જ આપણને આ ઇક્વેશન મળશે. સેકન્ડ ઇક્વેશન હશે રેઝિસ્ટન્સ ઓવરકમ કરવા માટે. રેઝિસ્ટન્સ ઓવરકમ કરવા માટે જે એનર્જીની જરૂર પડે છે એ ઇક્વેશન પણ આપણને રેઝિસ્ટન્સ ઓવરકમ કરવા માટે જે ટ્રેક્ટિવ ફોર્સની જરૂર પડતી હતી એના પરથી મળી જશે, કન્સિડરિંગ small r as the train resistance which is measured in Newton per ton. તો સ્પેસિફિક એનર્જી આઉટપુટ હશે ER equal to 1000 multiplied by WR by W multiplied by D1 by D multiplied by 1 divided by 3600. And the last one, that is energy required for gradient, જેને આપણે EG તરીકે ડિનોટ કરશું. તો ગ્રેડિયન્ટ વખતે જે ટ્રેક્ટિવ ફોર્સની જરૂર પડતી હતી એને આપણે FG કહેતા હતા. તો એનર્જી આપણને મળશે FG multiplied by distance. So finally the answer will be 27.25 multiplied by G multiplied by D1 by D. This equation is also obtained with the help of tractive effort which was required for overcoming the gradient. Now, so finally the total specific energy output we will get will be addition of all these three energies which were required during acceleration to overcome train resistance and to overcome the gradient. The final expression will be as you can see on the screen. Specific energy consumption ની વાત કરીએ તો specific energy output ને આપણી આવી equation મળી. Now specific energy consumption can be given as specific energy output at driving wheels divided by overall efficiency of the motors and gearing. This can be obtained by the simple equation of efficiency. Efficiency in equation આપણે શું કહીએ છીએ? Output upon input. So the equation of specific energy consumption will be output divided by efficiency. જે નીચે ઇનપુટ ડિનોમિનેટરમાં હતું એને આપણે ક્રોસ મલ્ટિપ્લિકેશનની મદદથી ઉપર લઈ જશું અને એફિશિયન્સી છે એ નીચે આવી જશે. તો આપણને મળશે ઇનપુટ ઇક્વલ ટુ આઉટપુટ અપોન એફિશિયન્સી. ઇનપુટ એટલે કન્ઝમ્પશન. સો કન્ઝમ્પશન વિલ બી આઉટપુટ અપોન એફિશિયન્સી એટલે કે ટોટલ સ્પેસિફિક એનર્જી આઉટપુટ divided by efficiency. So this equation which you can see on the screen will be divided by efficiency. So this is how the expression will look like. Specific energy consumption will be specific energy output at driving wheels divided by overall efficiency of the motors and gearing. So final equation આપણને મળશે 0.01072 em square divided by S efficiency multiplied by WE by W plus 0.2778 S1 by S multiplied by R by efficiency, which will be in watt hours per ton kilometer. So this is the final equation of specific energy consumption, and this was the equation for specific energy output. Moving further, the factors which affect the specific energy consumptions are given below. Now energy consumption in propelling the train is required for, first of all, having the linear and angular acceleration. Secondly, working against gravity while moving up the gradient. Thirdly, working against the resistance of motion. Fourthly, overcoming the losses due to gearing system. And lastly, supposing or we can say supplying losses in motors and other electrical system. So energy required being the product of power and time. Energy જે જોઈએ છે એ પાવર અને ટાઈમનું મલ્ટિપ્લિકેશન છે. It depends upon the power required and the duration for which the power is taken. So factors which affect specific energy consumption are firstly distance between two stops. બે સ્ટોપ વચ્ચેનું distance. પછી એક્સિલરેશનનો રેટ. પછી ટ્રેન જેટલી મહત્તમ ગતિ એટલે કે મેક્સિમમ સ્પીડ અટેન કરી શકે છે એ. પછી ટ્રેકનું જે લેવલ છે એનો નેચર, ટ્રેનનું જે રેઝિસ્ટન્સ છે અને છેલ્લે ટ્રેન ઇક્વિપમેન્ટના પ્રકારો અને એની ગુણવત્તા. That means types and qualities of train equipments. So these are the 6 factors which affects the specific energy consumption. As you know, the specific energy consumption of a train which is operating at a given schedule speed, it depends on these factors. Now we will discuss some terms which are related to specific energy consumption. પહેલી તો ટ્રેન રેઝિસ્ટન્સની જે આપણે વાત કરીએ છીએ જેને આપણે સ્મોલ આરથી ડિનોટ કરીએ છીએ. Now when the train is in motion, it experiences the resistance due to various reasons. The main reasons are rolling stocks ના અલગ અલગ ભાગો એટલે કે various parts of rolling stocks. Secondly, ટ્રેનનું જે ટ્રેક સાથેનું ઘર્ષણ છે એ friction at the track. અને ત્રીજું, the resistance offered by the air. એરના લીધે જે અવરોધ આપણને મળે છે એ. That is further divided into 3 main resistances: frictional resistance, head resistance, skin resistance and suction resistance. So these are the terms which are related to the train resistance. એ પછી આવે છે adhesive weight. Now talking about the adhesive weight, તો એ ડિસ્કસ કરતાં પહેલાં ડેડ વેઇટની વાત કરીએ તો ડેડ વેઇટ means the total weight of locomotive and the train which is to be pulled by the locomotive. એટલે કે લોકોમોટિવ ને ટ્રેનનું ટોટલ વેઇટ જે પુલ કરવાનું છે લોકોમોટિવને એને કહેવાય ડેડ વેઇટ. એક્સલરેટિંગ વેઇટની વાત કરીએ તો ધ ડેડ વેઇટ ઓફ ધ ટ્રેન, દેટ ઇઝ ધ વેઇટ ઓફ લોકોમોટિવ એન્ડ ધ ટ્રેન કેન બી કન્સિડરેડ વિચ two parts which are the weight which requires angular acceleration, angular એટલે કે weight of wheels, axle, gears etc. અને એવું weight which requires linear acceleration. So hence the effective weight which is greater than dead weight is called the accelerating weight. અને accelerating weight generally 5 થી 10% dead weight કરતાં વધારે લેવામાં આવે છે. તો adhesive weight ને આપણે કહી શકીએ કે the total weight to be carried on the driving wheels is known as adhesive weight. It is defined as the total weight to be carried on the driving wheels. So these are the few terms which we discussed for specific energy consumption. Thank you.